recent study by David Nagel highlighted the appearance of craters in a transition metal surface as potential evidence for a low-energy nuclear reaction. Nagel asserts that it remains to be seen if craters will be helpful in understanding the origin and nature of LENR, but already the existence and features seriously challenge theories that seek to understand it. We believe at HUG there may be a way to test this hypothesis in live video.
And it has just a slight purple tint to it because it's seeing the infrared in addition to the white light. All webcams, virtually every solid-state camera can see infrared, at least the sensor can. And most of the time they don't want it to see infrared. So they add a small filter inside. It's often part of the lens assembly. And it just blocks the infrared, and that's all the visible light through. For every camera it's different. Some of them are easy. You open it up and you just pull out a little plastic piece. This one it happened to be molded in the lens assembly, so it was a lot harder to get it out. But we managed to get it out without causing any other damage. At least not much. It works. As it gets hotter, the black body radiates at shorter and shorter wavelengths. And when you get just underneath red is about 660 nanometers, or 0.6 microns. When you're down in that range around 0.6 down to 1 micron, that's a temperature range about, well, you start to be able to see objects that are about 400 C. Here's a soldering iron that's about 500 degrees C. And if you look at that on the picture, you see it has a purple glow all the way around it. So it looks like it's its own light source. But of course, if you want to have software processing it, it's nice if you eliminate everything else. You can buy visible light blocking filters that transmit only infrared, and those can be kind of costly. But Wes managed to come up with this magic trick. Take a black magic marker and you put it on both sides of a piece of glass or a piece of plastic, and you put that in front of the camera, and it pretty much blocks out everything. But if we take our hot object and put it in front of it, it still sees that just fine. Yellow. There we are. And we put the blocking filter in front of it, and here's what it sees. We want to operate our wires in the cells at this temperature and hotter. The nice part about this kind of a camera, it can see through glass, whereas an ordinary calibrated thermal camera cannot see through ordinary glass.